Windows Azure Storage allows application developers to store their data in the cloud. The application can access its data from anywhere, anytime, and store any amount of data and for any length of time. Part of this storage is Azure Tables, the structured storage provided by the Windows Azure platform. Azure Tables provide a simple yet a highly scalable table storage solution in the cloud. Because you can store data in Azure Storage at the cost of 10 to 15 cents per gigabyte, Azure Table Storage is highly cost-effective when looking for a non-relational table storage solution. But why did I say non-relational? That's because Azure Storage Tables are non-relational. Do not think of Windows Azure Tables as equivalent to a SQL Server table. Windows Azure Tables are not relational. You cannot create relationships between tables. You cannot create primary keys and foreign keys. These are not relational, but they do allow you to store non-relational, highly structured data in a table. They're also hierarchical, meaning, although they're not relational, they are highly structured. So let's take a look at what an Azure Storage table looks like. Tables store entities. An entity schema can vary in the same table, and this is what's different between an Azure Storage table and a SQL table. You can create an Azure Storage table, and yet the schema can vary within the same table. So let's take a look at this. Again, I have my storage account, and one storage account can store multiple tables, and one table can store multiple entities, and the entities can be anything. Again, the entity schema can vary within the same table. But I can't stress enough that it is not relational. Windows Azure Storage tables are not relational. You cannot create foreign key relationships between the tables. You cannot perform server-side joins between the tables. You can't create custom indexes on the tables, and you can't do things like select count from a table, for example. When creating an Azure Storage table, the table must include several properties. It must include a timestamp, must include a partition key, and it must include a row key property. These three properties must be included on any Windows Azure Storage table. Here's a sample table that has three partition keys. Partition key 1 is partitioned by Kirk. Partition key 2 is partitioned by Archer. And partition key 3 is partitioned by Bender. And notice, though, that within the same partition key, you have different schemas. For example, one of the Kirk partition keys has a VIN number, while the others do not. And one of the Archer partition keys has a VIN number, while the others do not. Again, this allows the flexibility and the flexibility to partition and scale and provide the highly structured storage within a Windows Azure table. The great thing about accessing Windows Azure Storage, including tables, is the ability to access this information through WCF Data Service. You can create and consume your Windows Azure Storage data via OData. If you aren't familiar with OData, it is a REST-based API that Microsoft is heavily pushing. The Table Service REST API also implements the WCF Data Services API. And the great thing about this is that some of the features are extended to allow you to easily access and consume data stored in your Windows Azure Storage tables. Working with tables is quite simple and actually pretty easy. Tables can be created and destroyed on the fly in code, and you can wire up your storage on the onStart method. And you simply use the Cloud Table Client class to access the table and any of the entities within that table. So here's an example. We use the Cloud Storage account to get our connection information. And once we have access to our table, we can use the Create Table If Not Exists method to create the table. And then we can delete that table if it doesn't exist. So there are several methods as part of the Windows Azure SDK API to allow us to easily and efficiently work with the tables. The question is, how do you work with the tables in a .NET environment? If you're familiar at all with the Entity Framework, you should be familiar with the concept of POCO classes. This allows you to define your tables through code. And the Windows Azure API actually allows you to work with tables in the same manner. So this is how we would represent an entity in a normal .NET code. It is very commonplace. Basically, we define a class, and within that class, we define properties. So the class would equal our table, and the properties would equal the entities within that table. However, we said that there are certain properties that our table needs to inherit. And this can be easily done by inheriting from the table service entity class that will allow us to easily store our entity in an Azure table. So here's our movie class, and we inherit from the table service entity, and we simply include the partition key and row key. We don't need to include the date timestamp because that will be added for us behind the scene, but we include the partition key and row key and then just add the other properties for our columns. In this example, title, star rating, and description for movies. So here our class inherits from the table service entity, and we include the partition key and row key. Now, even though we've created our class, and we know that we're using WCF Data Service to access our data, the concept here is that WCF Data Services need a context class to be able to access that data. We may have a class that maps to our table, but that does us no good unless we define a context class that WCF Data Services needs to actually access that table. So we need to define a context class. And the context class is what represents our connection to the table. So here we're defining a movie context class, and we're going to and that class is going to inherit from the table service context. So let's talk about how you would add an entity. Adding an entity includes many of the operations when working with normal WCF data services. For example, you can do things such as deleting and updating and inserting. So let's take a quick look on how you would do that. So the first thing you would do is you would create an instance of your cloud storage account. Then the next thing you need to do is create an instance of the context, and in this case it's the movie context. The next thing to do is create an instance of the actual class, and in this case the movie class, filling in the properties with the data that you want to add to the table. And then when you're done with all that, you simply call the add object method on the context to add the movie object to the context. And then to save the changes to the table, you simply call the save changes method on the context, and this takes the data that you just added and saves that to the table in your Windows Azure storage. Deleting an entity is much the same way. However, you can keep the entity or use a lightweight copy for better performance, or you can just delete the entity if you don't need it anymore. But let's take a quick look on how you would delete the entity. Again, the concept is very much the same. Create an instance of your cloud storage account, create an instance of the context, but instead of creating an instance of the actual movie class, we can use the link syntax to query the table for the specific entity that we want to delete, and then call the delete object on the context, passing the entity that we just received, and adding that to the context, and then calling save changes on context, and that will delete the entity from the table. Another way to delete the entity is by simply calling the delete object and creating a new instance of the movie and passing the particular partition key and row key, and then calling the save changes on the context. Typically, in most systems, you do things one at a time. For example, if I'm working with a table, you might insert a record, then delete a record. From a queue perspective, you might place a message on a queue and then pull a message from a queue. But this has a cost on Windows Azure Storage. And we need to talk about the cost of Windows Azure Storage. Anytime you do a transaction in Windows Azure Storage, there's a cost associated to that. Now it's pretty cheap. It's 1 cent for every 10,000 transactions. But if you're in a highly transactional system, that could start adding up over time. So you want to think in terms of batching. So instead of pulling one message from the queue, maybe pull 10 messages or 20 messages from the queue, or maybe put 20 messages on the queue, because that's considered one transaction. Anytime you hit a queue, it's a transaction. So instead of pulling one off, maybe pull 10 off, and that's still one transaction. This same thing applies to tables as well. Instead of doing an insert, and then doing a delete, and then doing an update, you can batch those things in a transaction, and by hitting the table one time, that's still considered one transaction. This also has an impact on performance. By batching your transactions, you can certainly increase your performance. In this example, we're looping through 10 times, and we're simply adding the records one at a time. This is highly inefficient. Plus, it just cost us some money because we just hit the table 10 times. The better way to do that is to batch that. We're looping 10 times and saving that as a batch. And to do that, all that we need to do is on the Save Changes method just past the Save Changes Options.batch enumerator. Let's talk about how queries work. Whenever you do a query, that's obviously going to hit the table, but it's not like a SQL Server table where it gives you all the data back. Querying a Windows Azure Storage table operates a little bit differently. If your query returns in less than 5 seconds, it will give you all the results back. However, if your query takes between 5 and 30 seconds to return the data, you're given back a continuation token so that you can fetch additional results. If your queries are over 30 seconds, Windows Azure Storage has mechanisms in place to say, look, we don't want you to take and hog all the resources on this instance, so we're going to cancel your query. Don't panic about that, because we're going to talk about how to write efficient queries to query your Azure Storage tables. Along the same lines, when more than 1,000 entities are found, a continuation token is also returned, so you can get go back and get more entities. Here we're querying the movies table, and we're filtering on the partition key and the row ID, and then telling it to give us the first entity back. This query obviously will return in less than 5 seconds. Even if you're on a slow system, it still may take less than 5 seconds. And here's a good example of a query, but we're actually going to talk about this a little more. Now, the way to improve performance and actually save cost for transactions is to group things in transactions. Transactions are supported for entities in the same table and partition using a batch, and we talked about batches a few slides back. Transactions are limited up to 100 entities per batch, and there may only be one operation per entity in the batch, meaning you can't do an insert and update within the same batch. And the way to work with transactions is by using the begin save changes and end save change methods for asynchronous operations. Let's continue the performance discussion by discussing how is the best way to query a table entity. And the key is to use your partition key and row keys. These matter. For example, let's start from the bottom of this stack. If your query includes no partition key and no row key, that is going to be very slow. In fact, you can just look at this and know that it's going to return every row in that table. And again, you can store up to 1 terabyte in a table, so that query is more than likely just going to be canceled because it's going to return every entity in that row. Now, moving up the stack, a slower query is if you include only the partition key and no row key. But going back, if you remember that slide, there's still a lot of data that you can store in that table, so you could still be returning a lot of data. The best way is to include a partition key and row key. This is guaranteeing you to return the specific row that you want and get your data fast. Now, there's also a super fast method where you would use just a unique partition key, but both the very fast and super fast are guaranteeing you to return just the data you want and return your data within the 5 seconds. Let's take a few slides and talk about some best practices. You want to treat entity schemas as a data contract. Think in terms of Windows Communication Foundation contracts. You want to treat the entity schemas as a data contract. You also want to manage schema version as an entity property, meaning if your entity changes, you might have a property on there that specifies which version of the schema you're working with. Also, you might want to highly consider using the self-configuration and setup during the startup, meaning don't do a lot of the configuration and setup when it's running, but put that in the on-start method so that when you're running, you don't have that overhead. Now, one of the things we see a lot when we talk to customers is the use of SQL Server to store historical data. This bloats the SQL Server database and adds cost because you have to add disk space to your database. It's much cheaper then to take that historical data out and store this in Windows Azure Storage tables. So essentially, you want to use these tables as a cache of relational data. Move some of the data out from your SQL Server instance that you don't really use a lot and move that into Windows Azure Storage and cache that data there. So it's a cache of relational data. Cost, then goes down, and you now have much more disk space for your SQL Server instance. Now, one of the great things about Windows Azure is that the partitions are auto-balanced. You don't need to write any code to do any of the partitioning. This is handled by Windows Azure automatically. Hot partitions may also be scaled up automatically, meaning if you have a partition that's getting hot, that's getting hit a lot, Windows Azure Fabric may dedicate more resources to that partition with a high transaction load and scale those out, or scale and partition those out. In essence, the partition key and row key does equal a unique ID, so when you're querying, be sure to include the partition key and row key. In fact, if you're doing any creates and updates and deletes, you must include the partition key. There's no way around that. Any table is in triplicate, as is well the partitions. So anytime you do a select query, that select query is run across the partitions and are run sequentially. Now here's an important point. Some people may say, well, why can't I use a sequential partition key? Meaning you may have, in SQL Server, you may have an identity column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Why can't I use that as my partition key? Well, if you think about the way Windows Azure partitions, it partitions on the partition key. So if you have a sequential partition key, how does it partition? If you're using a sequential partition key, Windows Azure cannot partition that table. We talked about continuation tokens, and just as an FYI, continuation tokens may be returned from cross-partition queries. For example, if you're running a query and it has to cross-partitions, depending on what Windows Azure determines as the time it takes to return that data, it may give you a continuation token back. However, if you have a query that does not include the row key and partition key, Windows Azure will determine the length of the query and may hand you back a continuation token. Key columns can be up to 1 kilobyte in size, and when working with URIs, make sure that your URIs are 260 characters or less. And be aggressive with partitioning. If you'll only ever query something by a single key, use an empty row key and a unique partition key for a partition of 1. So let's talk about costs. We alluded to costs earlier. For 15 cents, you get 1 gigabyte of storage per month. This is actually really cheap. We talked about also storage transactions, meaning anytime you hit the table, you're querying the table, you're inserting or updating or deleting. That's 1 cent for every 10,000 transactions. So we talked about batching. Make sure that you highly consider batching when working with Azure Storage. Data transfers. Data transfers refers to any time you are moving data from source to destination. This could include moving data within the data center or from within the data center to outside the data center, for example, to on-premise. Anytime you're moving data and doing data transfers and that data leaves the data center, meaning you have data going from your data center to on-premise, for example, you get charged for that. So if you have data going in, that's 10 cents per gigabyte in. If you have data going out, that's 15 cents per gigabyte out. And you also see the prices for gigabyte in Asia and Europe. All right, with that, let's do a demo that illustrates the functionality of working with Windows Azure Storage tables. So let's build our Windows Azure table demo. And to do this, we're going to need Visual Studio again. So let's fire up an instance of that. For simplicity reasons, again, we're going to build another C# Windows application. So go ahead and click on the New Project link and select Windows, and we're going to create a Windows Forms application. And we'll call this Windows Azure Table Demo. And click OK. Here's our blank form. But before we start designing our form, we need to create our table class and our context. So let's go over to our solution and let's add a new class. And we're going to call this book.cs. And then we're going to add another class, and we'll call this book context. Now we need to define our entity. and the properties of that entity. Now, I could do a lot of typing, but I've actually got a lot of the code behind there, so I'm going to minimize this and go to a folder where I've got a lot of the code. So here I have a lot of the code, but I'm not going to copy all of it. Actually, before we begin, we actually need to go back and we need to add the Windows Azure storage references, since this is a Windows Forms project. So again, we need to click on Add Reference. Let's browse, and we need to go to our Program Files folder. So we'll go to Program Files. These files are located in the Windows Azure SDK folder, version 1.4, and then in the reference folder, we need to add the storage client, service runtime, and the diagnostics DLL. We don't really need to add the diagnostics, but if we want to add any diagnostics to this, we can add that as well. So let's add those. Now again, if you watch the Q demo, we talked about the issue of the project having an issue with these references. And that's because if we go over here to the properties of the project, the target framework is the client profile. We don't want that. We want just the standard .NET 4. So if we select that, it's going to say, hey, we need to close and reopen your project. Go ahead and click yes. So we've got our references added. We've got our 2 classes added. So let's go grab some code, because what we want to do first is define the entities that we're going to work with. So in our book class, we're going to add a few references here. So using Microsoft.Windows Azure. We're going to add a reference to our storage client as well. Okay. Now, remember when we went through the slide deck for tables that any classes that we define as entities need to inherit from the table service entity. So our book class is going to inherit from table service entity, and we do need to make this public. So we do need to do that. Now we can start defining what our entity looks like. So we're going to say public book. Now remember that every entity needs to include a couple of properties, and these 2 properties are the partition key, and we're going to set those to string.empty right now. And it does need to include a row key. We'll set that to string, because we do want to in our example, we'll want to specify those. All right. Now we can start adding other properties as well. So I'm going to hop over to my text, and I'm going to copy a few of these. I'm going to paste those here. In other words, my book is also going to include not only a partition key and row key, but a name, a price, the number of pages, the description of the book, and the author. Okay? I'm also, for the purposes of this example, I'm also going to define another entity. So let's create one more, and this won't be that big. So we're going to say public class author. And that also needs to inherit from the table service entity. And this, so public author. This also needs to define a partition key and row key. So I'm just going to, instead of typing, I'm going to come up here and grab these real quick. Scroll down here. And then I'm going to go back over here and just add 2 more properties to my author entity. There's the definition of our 2 entities. So we've created 2 entities, book, or we've defined 2 entities, book and author, and both of those have inherited from the table service entity. So we're done with our defining our entities. We now need to define our context. If you remember, the context is the one that communicates with WCF data services and has that connection with WCF data services. So we need to add a few references here as well. So we're going to say using Microsoft.Windows Azure. Instead of typing, you know what, I'm going to go over here and grab these as well, because you've already seen me add those. So I'm going to grab those, add these as well. There we go. Oh, we need to add one more reference. Since we're actually getting data, we need to add a reference to system.data and data services. So these are just standard .NET classes. So I can go down here. So system.data and data services. There we go. Oh, I forgot one more. We'd add a reference to client as well. Let's sort these alphabetically. Scroll down to system.data.services.client. There we go. Okay, now that we have those references, we have our context, but we need to add a few things to that as well. We know that our context does need to reference the table service context, so we need to add that. Now, because this is the one that's doing that's actually getting the data, here's where we need to define our account access and account key. So let's add, we're going to go back again, let's add a region where we can store that. So at region. And we're just going to say, and here the difference between this, because it's in the context, these have to be static. So static string count. And static string key. Okay, so we know I'm going to go back over here and I'm going to grab that's appdevq. I'm going to go grab a key again. I'm going to paste that here and then minimize it. All right, so we've got our region defined. But now I'm going to go over here and I'm just going to grab the code that defines the storage account credentials and defines the actual context. So here's the line that creates, just like our queue example, defines the storage account credentials, access, and key. The next line defines and gets an instance of our cloud storage account. And then we actually define the context using the credentials that we created. All right. Now, to allow us to actually query the Azure Storage tables, because we know that the tables are iQueryable, we need to define a couple of iQueryable properties. So we're going to say public iQueryable of type book. Call this books. And we're going to define a get property. And we're going to say return create query of type book books. Okay. There we go. Let's clean this up a little bit. Now let's do the same thing. We probably won't use this too much, but let's do the same thing with authors. So we have one here for authors as well. So we're just going to create one for authors. So we have also create a queryable object for authors that allows us to query the authors table. Okay. Now beyond that, we can actually create a few properties that allow us to add, update, and delete books and authors. So I'm not going to type all of those. So I'm actually go back over to our code and I'm going to copy these 4 statements. I'll explain what these do. Whoop, too far. All right, so I have just added 4 methods. Method 1 is add book and passes the name, the price, and the number of pages and description, and then adds that object to the via the add object, and then calls save changes. And we do the same thing for update book, delete book, and then we also have one for add author. So this is one example of how we could set several methods and create several methods to work with the Azure Storage table. We've defined our entities and the context to work with those entities. But what we haven't done is created those in Windows Azure Storage. We've set the framework for that using these 2 classes, but we actually haven't created those tables. And that's where we're going to actually go into the form and use the Azure API to do that. All right. Let's build this real quick, make sure there are no errors. So succeeded. So let's now go over to our form and start designing our form. And the form's going to have several controls on it. Go to our form. Let's make this a little bigger. And we're going to do two things. We're actually going to drop, for now, we're going to drop several buttons on there. And we're also going to drop a list box. All right, let's clean this up a little bit. So this is, we're going to have two buttons on here. We're going to have a list box on here. Size this up just a tad. All right, so first button, where's our properties? Our first button is going to be called Create. This is where we're going to write the code to actually create the tables in Windows Azure Storage. We're going to have another button on here that will actually pull the tables from Azure Storage and list those in the list box. We're going to say List Tables. And then this button will actually provide us the ability to delete a table that we select. So we'll say Command Delete. Delete table. There we go. And we'll name this List Table. Let's make this, there we go. Let's make that button a little wider so we can see the entire text. Okay, so let's start with that. We're going to add a few more things later on to show some of the other flexibility of Windows Azure Storage and the API. But let's start with this. The first thing we need to do is let's go to the code behind. And we're not going to put anything in the form load. So what we want to do is let's just right mouse click anywhere on the form and select View Code. And we also need to add the storage credential information here just for simplicity purposes to make things easier to work with. But before we do that, we're going to actually add a few variables up here. So we're going to say string table. And then right below here, we're going to copy the same region out of here and put that in our form. Now, typically you wouldn't do this, but just for the sake of the demo, we're going to do that. Let's hide that. All right. We want a general method that goes and gets the table. So we're going to create a new method called getTables. And this is what's going to allow us to just using our storage account and bring back a list of tables. I don't want to do a lot of typing, so I'm actually going to go over to our form. And I'm going to grab all of this. I'll explain what this does. So first thing we do is we set the cursor to a wait cursor. Oh, the first thing we have to do also is we need to go and add several references to our form. All right, so we need to add Windows Azure. And actually, you know what? Let's just copy them from here. Save us some time. There we go. Everything's good. So we first set the cursor to a wait cursor. We clear the list box, get our credentials, get an instance of the cloud storage account, create a cloud table client, because now instead of working with queues or blobs or things like that, we're working with a table client. So we get an instance of that and create an instance of the cloud table client. We then get an IEnumerable list of tables, calling the list tables method on the cloud table client, and then we can iterate through those tables. Okay. So this just gives us a general way of getting our tables. So let's go back to our form, double-click List Tables, and all we want to say here is we just want to call getTables. We have no tables. This isn't going to work right now. I mean, it'll run, it'll compile, and we can run it, but if we click the button, no tables will show up because we haven't created any tables yet. So let's do that now. Let's go back over to our form, double-click the Create Table button. And we want to kind of do the same thing. Again, we're going to be copy and pasting just a little bit to save us some time. So I'm going to grab these two pieces of information. But yet what we want to do here is we want to say cloud table client dot create tables from model. And here we're actually going to pass it the context. So we're going to say type of book context, and then pass it some information. So I say SCA.table endpoint. Actually, we call it cloud table. Oh, CSA. Sorry about that. CSA cloud storage account. Table endpoint. Absolute URI. And then the credentials. All right. And then we're going to call get tables again. So let's start with that. We have more to add, but let's start with that. Let's compile to make sure everything's good. So we'll say rebuild. We do have one warning. Oh, just because it's saying we haven't used this variable yet, and that's fine. We will use that variable shortly. So let's run. So we're running. Let's take a look at this code real quick, because what this code is doing is it's going to get the structure of our tables that it's going to create from our book context. So it's going to go over here, get from the book context, which actually references this structure. So it's actually going into our context to get the structure of the tables that it needs to create. So if we click create, right, there they are, right? So it actually went and created the tables in Windows Azure Storage and then called get tables, and there's our authors table and our books table. Very sweet. All right, let's keep going. We've now created our two tables, but we actually haven't added any data to our tables. So let's do that next. Now to do this, we're actually going to make this pretty simple. So we're actually going to drop a few text boxes on this form. We're actually going to put 7. So let's drop, and we'll just copy, paste, 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 paste. There should be 7. So 1. All right. 1, 2, 3, 4, 5. We have 7 text boxes. Now let's just drop a few labels on here, just so we know what data we're working with. All right, so we got 1, copy that. 2. I'm trying to go for some prettiness here. We won't try to be too long or too pretty. We're going after functionality. All right, so this one we're going to call, here's our partition key. This is our row key. This is our name. Let's make sure I get this right. So we got name, price, pages. Price, pages, this is description, and lastly, this is author. With that, we're going to drop one more button on this form. This is going to be called save, because what we want to do by entering data into these fields, we're going to be saving this data into the table. We'll just call this save. And let's add code behind that now. And the way we're going to do this is, as you saw on the slides, we're actually going to do the following. So we're going to define an instance of our context. So an instance of our book context. We're going to say var book equals new book. And now you notice as we start typing, the properties of this entity will start popping up. So we can say partition key equals, now we know that this should be text box 1, 2, 3, 4, 5, 6, 7. So just to save time, I didn't rename those. This is going to be text box 1.text. I'm actually to save time, I'm going to copy that as well. So this is a comma. Our row key is text box 2. Our name is text box 3. Our price. Now the text box is a string, so we actually have to convert this because we defined the price and the pages as a double and an integer. Remember, if we go back and look at this, we know that our the price is a double and our pages are an int. So on our form, in our code, we have to account for that. So we say convert dot to double, and we say text box 4.text. And we need to do the same thing for price, or for pages, rather. But this we needed to convert to an integer. So say to int 32 text box 5.text. And we have description, which is text box 6.text. And lastly, we have author. Oh, what happened there? Let's go back. Oh, we don't need it. Next we have author, which is text box 7. Oops, 7. All right, when this code runs, it'll fill that information out, grabbing the data from those text boxes. Now we're going to do context.addObject. We're going to pass it the variable that we defined above, so at table, but we haven't set this yet, so we need to go back and add the code to set that variable, and then we pass the book that we just created, the value of this book. And then lastly, to usher our changes back to the table and save those changes, we just say context.saveChanges. Okay, so there's our code to save. However, we do need to set the table variable. So this is as simple as going back to our form and simply saying table equals list table dot selected item dot toString. All right, that gives us our table. We'll be adding a little more to this selected index change event of the list shortly. All right, with that, we should be able to run this. Let's compile it again. Make sure everything's working. All right, all succeeded, no warnings, no failures. So let's run this. We have to list our tables. There they are. We're going to add to books. So now that our table variable, our underscore table variable is set, and it should hold the value of books. Now we're going to add a row key, or actually add an entity to our table. So let's start with the partition key. We're going to call this Azure with a row key of 1. We could actually put anything in here. It could be a date, time, something unique. Right? We're going to call this ProSQL Azure. Call this $39.99. Say it for 400 pages. The descriptor is awesome book, and the author is me. Okay. Let's go back and make sure we got that. So it should save changes. Now, realistically, what I should have done is put a message box in here that said, okay, that popped up a message box and said save successfully, but we'll go ahead and just click save. And we're going to assume it's saved. But we're going to add code here in a second that will actually show us that it's saved successfully. We can make that assumption because we didn't get any errors. So let's close this now, and let's go back to our selected index changed method, and let's add a little bit more. Okay. The first thing we want to do, though, however, is let's drop a data grid view onto this form. Let's make this form a little bigger. Again, we're not going after prettiest, so please don't make fun of my UI skills. That's good. All right, let's go back to the code for this, and let's add a little bit of code. So here we're going to, just because we want to know when things are working, we're going to say this dot cursor equals cursors dot wait cursor. Now let's define an instance of our context, because we're going to use this to actually query the table now. So let's say new book context. Now let's query. So we're going to say var books equals from item in context dot books. I'm just going to select item. What we're going to do now is bind the results of this query to that data grid view. So we're going to say data grid view dot data source equals our query books dot toList. All right. So let's save that. So now when we list our tables and click on the table, all the entities in that table should populate in that data grid. Now, however, we've only added one, so it should only populate one. So let's start our app, list the tables, we'll click on books, and there we go. So we have, there's the actual data that we added. I didn't set the cursor back to a normal cursor, but we'll fix that in a minute. So there's our data. Let's finish this example by doing a couple more things. Let's further add to this selected index changed event by taking the data from the individual properties in that table and repopulating those text boxes on the form. Okay, so I'm going to write the query for that, and then I'll go grab some code from my text file to populate that. So we're going to say var book equals, now here we're writing a link query, and here we're going to use the actual partition key and row key that we talked about earlier for performance. So we're going to say from item in context dot books. I'm going to apply a filter to this. We're going to say where item dot partition key equals, and we're just going to say Azure. Going to hard code that, and item dot row key equals, we need to convert that back to a string. We're going to say convert dot toString 1. So we want to say where the row key is 1, and then select item, and we want to grab the first one. Okay, there we go. Now I'm going to go over here to the code. I'm just going to grab past it. That's what I want right there. Grab that information. I'm going to paste that right here. Okay, because now I'm actually grabbing the specific properties for the entity and then populating the corresponding text boxes for that data. All right, there we go. Let's run this. Let's compile it first to make sure there are no errors. There shouldn't be. Okay, we're good. Let's run this. Actually, you know what? I want to set the cursor back. So I'm going to say this dot cursor equals cursors dot default. All right, now we can run this. So I'm going to list my tables, select books. There we go. It bound the results of the first query to the data grid and then populated the text boxes based on the second query. All right, let's do one last thing. Let's put some code behind the delete table button. So let's stop this, and let's go back into our delete table. And we're going to do the same thing. We're just going to go grab a little bit of code here. And we're going to say cloud table client equals create cloud table client dot delete table. There's our table. called get tables. And here we're going to throw up a message box that shows table deleted. All right, there we go. Very simple. Okay, so let's compile this, make sure there are no errors. All right, we're looking good. So we're now ready to run this, so let's go ahead and run this. Let's list our tables. Now let's delete the authors table. So if we click the authors table, it's actually going to pull up data for the book, and that's because if we go back to the selected index changed event, you'll know that we're querying data for the book. So it's not taking into consideration what table we pull up. So regardless if we pick book or author, it's just going to pull up the data for the book. Realistically, if we wanted to, we could put a switch or case statement in there to say, hey, if I select the author table, pull this. If I pick the book table, pull that. But in this example, it's very simple. So regardless of whether I pick authors or book, the code is going to pull the data for book. But in this example, what we want to do is we want to delete the author table. So let's go ahead and select the author table and click the delete button. Table deleted, and you'll know that it called the get tables. Now we only have the books table. We could actually go in again and click the create table button again, and the SDK would go and create the tables again, but it wouldn't create the books table again because it already exists. Because this event would be calling the create tables from model method, that method would go look and say, well, we already have the books table and we don't have the authors table, so let's go create the authors table. So clicking that button again would not cause any harm. So let's go ahead and do that. Let's click the create table, and you'll notice that the authors table is now created again. It did not create a second books table, so all ready to go. But the code behind the click event of the list box only pulls the information and data from the books and not authors. So there you have it, a very simple example of how to work with Windows Azure tables. We created some tables by creating a context and the defined entities, and then we added data to that and showed, using link queries, different ways to query our Windows Azure tables. One of the main themes of the Azure platform is that of loosely coupled, tightly integrated. The ability to work with one, all, or a mix of the different components of Azure. The previous demo illustrated how to work with just tables. But let's do one more example, which will show how easily work with both tables and queues. I've already fired up Visual Studio, and you'll notice that in this solution, there are 3 projects. I have a queue table app, and this is a Windows Forms application. I have a queue table client. This is a console application. And then I have a queue table server, and this is also a console application. Since we're working in on-premise, we did need to change the target framework from 4.0 client to 4.0, and I already have added the appropriate references to the storage client and the system.data.services.client reference. And I've done that in all the projects where appropriate. I've already designed the form, but I have no code behind these, and we do need to add a few more things. So let's start with the application. Let me explain what these do. The queue table client is simply a console app which will allow you to place messages on the queue. Very simple. The queue table server is also a console application, and that is responsible for picking up messages on the queue and displaying them in the command window, but also taking those messages that it picks up and placing them in the Windows Azure Storage table. That's where this queue table app Windows application comes in, because the Forms app will actually pull those messages from the table and display the messages that are in the table. Let's build this real quick. Let's start with the table app. So we do need to do one thing, so let's add a new class to this. And we're going to call this message.cs. And there we go. We're going to change this a little bit. Let's add the components that we need. So we need to add a using statement, our storage client, and we also need to using Microsoft.Windows Azure. Okay. This needs to be a public class. We're going to say public class message. And this also needs to inherit from the table service entity, because we're going to define our table in our context here. So what we're going to do is we're going to say public message and then we're actually going to define our table here. We'll do our partition key. We'll just hard code this. Our row key, and our row key is just going to be a new GUID. We'll do the date added as well. This will be a date time and a message. Perfect. Down here we got to add a few more things. So here's our public string message. And then our public date time. Date added. And this will clear up those the error above. We'll just copy paste real quick, make save time. All right, there we go. So there's a definition of our table that we're going to create in the Windows Azure Storage table. And the next thing we need to do is we need to create our context. So I have some code over here. I'm just going to grab this code. Whoop, not in there. We're going to go to code, to QTable, and I'm just going to grab this section of code right here. Let's go back to my form and let's just paste that right there. We're in my class. There we go. All right, so there's our table and there's our context. So let's go to our form and let's add the code to our form. And we need to do a couple things there. So I'm going to go grab some information up here. So the first thing we need to do is we need to grab and create the method that grabs our storage credentials. So I'm going to just put that down here. And we've already defined in a region our count credentials, our count and key. And we're going to use that to define our credentials. And then let's go back and we'll add the code for the click of the link. We'll just paste that right here. Oh, too much. There we go. We're going to get a warning with that because we're not using the EX declaration, but that's fine. So basically we're defining a URI, we're defining the message context, and then we're using that context to query the table specified in the text box. So if we open this real quick and look at this, let's look at the form. It's a very simple form. We just have a text box that specifies the table name, and then on the click of the refresh link, it will go query that table specified in the text box for all the messages that are in the table and bind those results to the data grid view that is right here. All right, so we're done with the Windows Forms application. That's very simple. So let's move on to the table queue client. Again, this shouldn't be too difficult. Very simple. All it is in the program.cs. We're simply going to make some modifications here. So we do need to add a few statements to the top of this. Same using statements. So Microsoft.WindowsAzure.StorageClient and Microsoft.WindowsAzure. Wonderful. All right. What we need to do here is we need to basically do the same thing we did on our form. Is we need to create the storage credential piece. So let's go back and we're going to grab that. We're going to go down to our client. And we're going to grab this section of code right here. We're just going to paste that right there, and it really does the same thing. It defines our credentials, and that's the credentials we're going to pass to gain access to the queues. All right, so the next thing we need to do is we need to define a method, and this method really just is going to check to see if the queue exists. So we're going to say private static void ensure queue exists. Now I've got that code over here. And essentially we're just doing the same thing. We're going to define the URI. So remember, everything is REST-based, so we have to specify the URI we're going to go get the queues and messages from. And we just define a new Cloud Queue client, a new queue, and then pass it the name of the queue, which is, in this case, we're just going to call it test queue, and then create that queue if it doesn't exist. The next method we need to create is called send message, because what we want to do is, as we create a message, we want to place that message on the queue. So we're going to create another method called private static void. Just simply call this send message. We're going to pass it the message. And again, to save time for typing, I'm going to go grab this code, and this is right here. And essentially it does the same thing. So it defines the URI because we're dealing with REST-based calls. Within the a try-catch block, we're defining the Cloud Queue client. We're defining a Cloud Queue to see if the queue exists, and we're getting a reference to the queue. We're defining a message, and then we're adding a message to the queue. All right, we're almost done with this one. Let's go, and so let's do one more thing, and let's just in our startup main method, here's where we're going to do a lot of the work. So we're simply going to do the following. So we're going to call this the ensure queue exists method, because we want to make sure that the queue exists when this runs. If not, we want to create it. And then, since this is a console application, when the command window comes up, this is where we're going to do all our work for placing messages on the queue and typing the message that we want to place in the queue. So we're going to say console.writeLine, and we'll simply say client message application. We'll do the same thing here. Here we'll say send, and we're just giving some instructions on how this works. So send an empty message to exit, and then we'll do this. All right, and then we're going to say while true, we'll say console.write enter a message. Then we'll define a string of the message, and we'll take the message that they type and insert it into this variable, into this message variable, read line. So we're going to take what they type and insert it into this variable. And then we call the send message, which actually places that message on the queue. And then we're going to say if message equals an empty string per the instructions above. Whoop. We're just going to exit. All right. So there, our client is done. So we're simply ensuring the queue exists. When this application starts up, it will display a command window with this information and allow us to type in a message. The message we type in will get placed and sent to the queue via the send message method, which is down here. So we're simply getting a reference to the queue via the REST URI and then placing that message on the queue. So we're done now with the client. Let's move on now to the server. Now, server's a little more complicated, but not much. We do need to do a couple things to this one. We do need to add one more class to this project. So we're going to add a class. We're going to call this the same. We're going to call this message as well. Okay, so let's start with this. Because, again, it's the same thing. Because this is very similar to the message class that we created in the Windows Forms application, because it does need to do the same thing. It does need to get a reference to the table to place the messages that it pulls from the queue into the table. So that you'll see that this code is very similar. However, we do need to add the appropriate statements. So Microsoft, Windows Azure, and using Microsoft Windows Azure .storage client. Wonderful. All right, so again, this is going to be a public class. And again, this needs to inherit from the table service entity. And now that I think about it, you know what? I'm going to go back to my message here and make sure, yep, that I did inherit from the table service context. Just want to make sure I did that. All right, so we're actually, since this is very similar, I'm actually going to go back here and grab this code. Not there. Grab that. And I'm going to do the same thing here. So I'm going to say public class message context. This needs to inherit from the table service context. And I'm just going to go back to this original one, and I'm going to grab this. Oh, not that far. Just going to grab that. I don't need that anymore. I'm just going to grab that. So this is the same thing. This is the same message class that is used in the, just for simplicity reasons, the same class that exists in the Windows Forms application, because this class also needs to talk to the Windows Azure table that's going to be pulling the messages, putting the messages in once it pulls them off the queue. All right, we're done with that, but now let's go into the program.cs, because this is going to do most of the other work. All right, so we've got several methods here as well. So we also have the one called public static, and we're going to call this stored. This is the, before we go any further, we do have to add the statements above, or else we won't be able to use them. Using Microsoft.Windows Azure .storage client, and using Windows Azure. Great. There we go. Okay. This is storage key, get credentials. All right. We're actually going to go down here. We already grabbed that. We're actually going to go and we're going to grab this from this code, so we don't have to do a lot of typing. All right. There we go. So same thing, we're basically setting some credentials and returning those credentials because we're going to use those credentials to obviously get access to the queue in the table. Our next method, we need one more method, and this method is the method that's going to take the message from the queue and save that message from the table. So this, we're going to call this private static void save message to table. And we're going to pass it the string, because this is the message we're going to be putting on the table. So again, I have this code right here. What this does, again, it defines the URI because we're talking REST. It defines the message context, and then on that message context, it adds the object of the table, passing it the table name and then the message to add to that, and then save changes. So the save changes is the call to actually save the changes and insert those records into the Windows Azure table. Our next method is we're going to call ensure table exists, so private static void ensure table exists. Now, same thing. We saw this in the function similar or method similar to this in the Windows Forms app. We just want to ensure that the table exists. So I've got that code as well right here. And really, it's doing the same thing. So defining the URI, creating an instance of the Cloud Table Client because we're working with tables, and then calling the create table if not exists method, passing up the table name. And that method is part of the Cloud Table Client class, just essentially saying, create this table if it does not exist. And we'll be calling this method from the run method when the application starts. We need to do the same thing with the queue. So we're going to create another method called ensure queue exists. And I've got that code right up here. And essentially it does the same thing. So it defines the URI, creates an instance of the queue client this time, and then an instance of the queue, and passing it a name of the queue that we want to get reference to, and then calling the create if not exist method on the cloud queue. All right, almost done. We do need to create a method that will actually pull the messages from the queue. So we're going to say private static void, and we're going to call this wait for next message. Again, I have that code, so let me go back and do that, and we're just going to grab, let's go grab this right here. There we go. Oh, sorry. This needs to be a string. There we go. That fixed the return message. Okay, so essentially we're getting the URI again, but then we're looping, and we're simply looping and then sleeping for a second, and then we're getting the Cloud Queue, an instance of the Cloud Queue client, getting a reference to the specific queue, and then we're calling the get message off the queue to pull the message off the queue. It's simply looping, sleeping for a minute, grabbing the message off the queue, and then deleting that message, and then returning that message. So this will also be called from the onRun, from the run method. So let's do that now. And it's not the run method, it is actually the main method, so my apologies. All right, so let's add that code. So this is very simple. So first thing we're going to do is call the ensure queue exists. We want to make sure that the queue exists, and then we're going to call the ensure table exists because we want to ensure that the table exists. We're then going to do, since this is a console app, a write line, and this is the server message application. Let's just save our time typing. Waiting for a message. And then one more. All right. And then let's loop, and simply loop to pull the messages off the queue. So while true, here we're going to say string message equals, and then simply we're going to call the wait for message, which is simply going to pull the messages off the queue. And then we're going to check to see if the message is empty. And if it is empty, we're going to exit. This, in essence, has reference to back to our client, where we're saying, let's go back there, we're saying, hey, if we pass an empty message, we want to exit. So back on the server, if we pass an empty message, we want the server to exit as well. So it'll pull an empty message off the queue and say, hey, there's nothing, so we're done. So let's exit the server application as well. So if there's not an empty message, we're going to save message to table and pass it the message. And then we're going to console dot write line. I'm going to say received message. All right. So in essence, what we're doing in this method, in the main method, is we're first calling ensure queue exists to make sure the queue exists. We're then calling the ensure table exists to make sure the table exists. We're putting up some messages to let you know what this application is really doing, and then we're looping. And while we're looping, we're calling the wait for next message, which in essence down here is simply looping and pulling the next message off the queue as it comes in. We then look, as it pulls a message off the queue, we then look to see if that message is empty, and if it is, exit. Otherwise, we want to take that message and save it to the table as well as write it to the command console. All right, so we're all done writing our code. Let's compile this, make sure there's no errors. All right, 3 succeeded, 0 failed. The way we're going to run this is let's first start up the Queue client. And this is where we're going to type in the message. You can make this a little smaller. Let's start up an instance of the server. And notice it's waiting for a message. And lastly, let's start up an instance of the app, of the Windows application. There we go. All right, let's minimize that so we can see all the windows. Actually, we don't need this anymore, so let's close that. And let's close that. So we get a nice, pretty window. All right, so in essence, what should happen is if I type a message in the client, it should automatically appear in the server as well. Now, it shouldn't automatically appear on the form because we need to click refresh. So let's at least start with the client. So we're going to type a test message. So this is a test message. We hit enter. Bang, there we go. We received on the server. This is a test message. Let's do another one. This is another test message. Hit enter. There it goes. So it picked it up from the server. So now, in essence, we should be able to go to our form, click refresh, and there we go. It pulled the messages from the Azure table that were written to the table by the server and displayed those in the Windows Form application. So this was a simple example on how to use queues and tables together. We've got the client that takes the message and writes and places those messages on the queue. The server component or the server application that picks those messages up off the queue and writes those to the Windows Azure table. And then we have the table, the Windows Forms application that upon clicking the refresh link pulls those messages from the table and displays those in the grid on the form.